This is an AQA A-level chemistry question on the Equilibria topic. You can have a go at each question as you go through and then review your answers. So here is part A, part B, part C, and finally parts D and E. In total, a 12-mark question. So going back to the answers now, we have colourless solutions of X and Y making an orange solution of Z, and we've got the equation provided. We can see the enthalpy change, we can see the molar ratios of X and Y and Z. Student added a solution containing 0.5 moles of X to a solution containing 0.5 moles of Y and shook the mixture. After 30 seconds, there was no further change in colour. The amount of Z at equilibrium was 0.2. Deduce the amounts of X and Y at equilibrium. Now, the table method is by far the most effective way of answering questions like this. I've got my equation, I've rewritten down below, and I've built the table around it. So I have my initial moles and my equilibrium moles. And what I can then do is take all of the information that the question has provided, and I've colour coordinated so you can see where they've come from. My two initial moles of the X and the Y, and my equilibrium moles of Z. Now, there are assumptions we can make here. We didn't start with any Z, so that becomes 0.00. For the rest of them, we've got to do a little bit of calculation. 1 mole of X makes 1 mole of Z. And that means that 0.2 moles of X would have been needed to make the 0.2 moles of Z. So I can then work out that if I started with 0.5 moles of X and I used 0.2, I have 0.3 left. In terms of the Y, it is slightly trickier because 2 moles of Y makes 1 mole of Z, which means I would need 0.4 moles of the Y to make the 0.2 moles of Z. So that goes down by 0.4 and we get a value of 0.1. For the next question, we have got a graph to be drawn to show how the amount of Z changed from time of initial mixing until 60 seconds had elapsed. If we take a look through, you're going to get 1 mark for putting on all of the units, the labels, and the figures in a suitable scale. You should be using more than half of the space provided. Now, from there, you're going to get a mark for the fact that after 30 seconds, there was no change in colour. That tells us there was no change in concentration. So we're getting this curve that flattens at 0.2. Moving on to part C, the student prepared another equilibrium mixture in which the equilibrium concentrations of X and Z were 0.4 and 0.35. This time we're given the Kc value, and you have to work out the value for the concentration of Y at equilibrium. So for this, we need the expression for Kc. Remember that it's products over reactants. Remember also the square brackets because they represent concentration in moles per decimeter cubed. Now, because I want the Y, I need to rearrange it. So the Y squared is Z over X times Kc. You can see there's a slight error here. I'm going to delete it because the Kc should not be in square brackets. Now, as we move on to the actual calculation, then we need to square root all of that as well to get to the final answer. So we get Y is the root of Z over X times Kc. I can then put the figures in, all of those have been provided, and that takes me to the value 0.5493, but I've still not got all of the marks. We have been given data to the value of 2 significant figures, which means our answer should be rounded to 2 significant figures. Moving on to part D, students added a few drops of Y to the equilibrium mixture of X, Y and Z in part C. Suggest how the mixture, the colour of the mixture changed and give a reason for your answer. I've added a little bit of information from earlier in the question. Colourless solutions of X and Y react to form an orange solution of Z. Now, what we're going to see here is it's going to darken, it's going to get more orange. And this is taking us back to Le Chatelier's principle. The equilibrium will shift to the right, and that's to oppose the increase in the concentration of Y that you have imposed on that system. Finally, for part E, colourless solutions X and Y react to form an orange solution of Z according to the equation. The student warmed the equilibrium mixture from part C. Predict the colour change, if any, when the equilibrium mixture was warmed. Now again, I've provided some information from earlier in the question. Key to this is that we have got a delta H of -20. The colour would fade. Now, you're not asked why here, but remember, if the forward reaction is exothermic, increasing the temperature would favour the reverse reaction. That takes us to the end of this question. Thank you for listening.